Hard water and soft water. Have you ever heard this word hard water and soft water? What is there in water to give the prefix hard and soft? Sometimes when you drink water, you feel some salty. It is so salty. But the water taken in this tumbler, when I consume, this is very good to taste, very good to drink. So, what I feel very easy to drink is soft, somewhat soft. What I feel somewhat difficult to drink is hard, that consists some salts. So, hard water usually consists some carbonates, that too bicarbonates. Usually, calcium bicarbonate and magnesium bicarbonates are the salts, that too soluble bicarbonates present in water make water so hard. So, hardness of water is due to the presence of soluble calcium bicarbonate and soluble magnesium bicarbonate. So, when you have this hard water in your house, how can you make it all right for drinking purpose? That is our special topic today. Temporary hardness and permanent hardness are the two different types of hardnesses there in hard water. When you have temporary hardness, the water consists calcium bicarbonate and magnesium bicarbonate. Calcium bicarbonate is CaHCO3 twice. Why twice? Because the valency of calcium is 2. So, calcium bicarbonate and magnesium bicarbonate MgHCO3 twice. These soluble bicarbonates when present in water, then the water made into hard. That hard is here called temporary hardness. When these two soluble bicarbonates present, that water is called temporary hard water. That temporary hardness of this hard water can be removed by some methods. The first method is the hard water that consists these two soluble bicarbonates, calcium bicarbonate and magnesium bicarbonate, is just boiled. Boil this. So, what happened? This is soluble calcium bicarbonate gives a precipitate of calcium carbonate, CaCO3. What are the other possible byproducts formed in this equation? Calcium carbonate plus carbon dioxide gas plus water byproduct. There are two carbonates in left side of the equation. In right side, you have retained one carbonate in product side and one carbon dioxide liberated from one of the carbonates among the two. Now, remaining is one oxygen, single oxygen and double hydrogen. So, that double hydrogen combined with the oxygen released from one of the carbonates to form this water byproduct. So, calcium carbonate plus carbon dioxide plus water byproduct. This calcium carbonate is precipitate. So, this soluble bicarbonate produce the precipitate calcium carbonate. And in the another equation, when you boil water, the another soluble bicarbonate is magnesium bicarbonate. When the water begin to boil, this bicarbonate forms magnesium carbonate, MgCO3. As earlier in the first equation, here also we have the liberation of carbon dioxide plus water. And this second equation further proceeded Magnesium carbonate here further undergo hydrolysis reaction by the action of this byproduct water to form magnesium hydroxide. Magnesium carbonate, MgCO3, undergo hydrolysis reaction by that water, H2O, to form magnesium hydroxide, MgOH twice. Plus, carbonate liberates carbon dioxide gas. To balance this equation, you know this water is a composition of H and OH. Carbonate releases one oxygen to form carbon dioxide. So, that oxygen, released oxygen, goes to this water to make this hydrogen as OH. Totally we get double OH. That double OH combined with magnesium to form magnesium hydroxide. So, in the boiling of hard water to remove temporary hardness, the bicarbonates form carbonates of calcium or hydroxide of magnesium. These two are after removed from the hard water, we get soft water. And in the second method, that is called Clark's method. Clark's method. In Clark's method, we take a hard water that consists of calcium bicarbonate and magnesium bicarbonate, CaHCO3 twice, MgHCO3 twice. Here it is treated with lime water. Lime water is nothing but calcium hydroxide, CaOH twice, calcium hydroxide. When calcium hydroxide added to hard water that consists calcium bicarbonate and magnesium bicarbonate, that is the salt responsible for temporary hardness, they are reacting here with calcium hydroxide, nothing but lime water, to form calcium carbonate. As we have double calcium here, we will form 2 calcium carbonate, CaCO3, plus 2 water molecules. How 2 water molecule? Here 2 hydroxy combines with 2 hydrogen to form 2 water. And here 2 calcium and 2 carbonate forms 2 calcium carbonate. This calcium carbonate is insoluble salt. In the second equation, magnesium bicarbonate when reacted with lime water, calcium hydroxide, that forms calcium carbonate, CaCO3, plus magnesium forms its hydroxide. Magnesium hydroxide is MgOH twice. Is there any other possibility to form byproduct? Yes, water is a byproduct formed, H2O. How? Here 2 carbonates are there. Among the 2 carbonates, we have written only 1 carbonate in right hand side. So, you write 2 carbonate, so that the calcium becomes 2. So, 2 calcium hydroxide. So, in 2 calcium hydroxide, we have totally 2 into 2, 4 hydroxy. Among the 4 hydroxy, we will retain 2 hydroxy in magnesium hydroxide. The remaining 2 hydroxy combines with these 2 hydrogen to form 2 water molecules. 2 water molecules. That is the proper balancing of this second equation. So, what is happened finally in Clark's process or Clark's method? The water, hard water that consists calcium bicarbonate and magnesium bicarbonate that make temporary hardness to hard water, that will be removed in the form of carbonate, calcium carbonate and magnesium hydroxide by the action of lime water, calcium hydroxide. Clear?